Let's see now. Now the difficult thing, how do I put this thing into full screen? Bottom right. I'm not. It was a rhetorical question. Yeah. Bottom right. Yeah. 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 You see how? Okay. Now I see the problem. This is the problem. Oh well. Yes. So my name is Mårten. I'm here to talk about what I call cheekily literal beautiful code. And I was walking around in this avenue with this speaker badge showing off, and I was approached by people saying, "What are you going to talk about?" And I say, "I'm going to talk about the shader art introduction." And they say, "What is that?" Well, that I promise you, you will learn nothing in this presentation that is useful for you in your work. So I mean, I was joking, lock the doors, but really it was so you wouldn't storm out of the building, right? Because now you know this is not going to help you in your work life, but perhaps you find a new hobby. That is what I'm really hoping for. And what do I mean by literally beautiful code? It is, well, if you go back a little bit, it is a little bit, we talk about beautiful code as coders, and when we talk about code and we say, look at this code, it's so beautiful. But the only people that can really appreciate it is coders, other coders, and coders in the same language. And my mother has many good qualities, but she's not a programmer, and she wouldn't be able to say, why is my C# code so much better than, for example, the C64 code or the COBOL code? For her, it doesn't make any difference. It's just text. But she could have an opinion on this thing here, where it looks like this, and everybody can have an opinion, and you might not even like it. You might say, "Oh, this is bland and boring," but at least I think everybody can have an opinion whether it's beautiful or not. And when I talk about beautiful code, it's code that generates things like this. So to give a little bit backstory, my name is Mårten. I don't know if I said it. I'll say it again. And a few years ago, programming got a little bit dull to me. I kind of reached where I'm satisfied in my career. And I was thinking, what should I do to sort of, spice up my programming life a little bit? And as many people, what I'm doing at work is kind of writing ERP integrations and database migration and ARM templates, and it doesn't help. It's called Bicep. It doesn't really, spark my, it tingles down my spine. Really, it's still kind of it's not really what I got into, because the applications I build look kind of like this, which I think some of you might recognize, and I think these kind of applications are, what is this thing there? These things here are important for us, and important maybe for society to work in the way we are, but it wasn't really the reason I started programming in the old days. So I tried to do a little bit of FOSS work here, right? And as some of you see here, I got 3 stars on my FOSS project, one of them for myself, and I'm also watching my FOSS project. But as you see, I don't feel I really succeeded sort of to do. And I must be honest, for me, I realized after a while, if I succeed as a FOSS developer, I just get more work after work. And I'm not sure that's what I wanted. So I got into programming to do cool graphics. That's really what I, in the late 80s, 1980s, I saw cool graphics, and I thought to myself, this is what I want to do. And when I say cool graphics, today it's not very cool, but we were into things that called demos at that time. At least I was. And I was kind of a nerd, but not everybody was into demos. But some of us, I was into demos. And I felt this was really cool stuff on my old Atari. And I especially remember this screen here as something I saw at my friend's place on his crappy little TV, this small, on his Atari ST, and my mind was blown by this amazing piece of thing. Because on the Atari you can have more than 16 colors, but there are more than 16 colors on this screen. How do you do that? And these balls are bouncing around, there's cool music, this text is moving. I never seen my computer do that before. So when I went home that day, I said to myself, I need to start programming assembly language, because that is the only way I can do this. I didn't really do this, I didn't really succeed, but this is the reason I kind of got into it. So then, a few years ago, I discovered a page called ShaderToy. And then I started doing things like that, perhaps, on the screen. And that thing tingled my demo nerve, or whatever you want to call it. That is sort of what brought me back to the good old days. This is what I wanted to do. And this is sort of, what I want to tell you a little bit about, or maybe this thing as well. And I even got a little bit of recognition when I done this as well. So I don't particularly driven by the recognitions. This is not really my motivation, but I don't mind to see that people are enjoying what I do. In this case, I got 137 likes on this one, and for me, that makes me happy. It will never not. I don't know how to put the right number of negations here, but it will never not make me not happy. You get what I mean, to get likes. So, I want to introduce you. Did I go the right direction? No. Yes. So what I want to do here is I want to share how to get started writing shader code, because this is shader code. And one way to do it is to actually use what is called a ShaderToy, which is a website. You don't have to install the thing. It works on Mac, PC, whatever. It uses WebGL. And this is where I started. And there are many, many examples here on ShaderToy that you can see on every different level. This is not the tool I'm going to use today, but it's perfectly valid. Then there's a cool guy by name Evil. I don't know why. He doesn't seem so evil to me, but he has created this site, which is a brilliant piece of site, because it's a little bit cooler than ShaderToy. And I want to recommend that as well to try out, but it lacks an important thing, and it lacks the community. ShaderToy has a community. He doesn't want to have a community. He's a weird guy, so there is no one. But it's a really cool site, and I want to put it out. You can code shader code up there. And then, if you prefer the desktop experience, there is the classic Bonsamatic, where you can do sort of shader coding on your desktop, and you see the screen background here. Things are happening. And by the way, I just mentioned that this kind of scene, it could be, in this kind of scene, you could have like a scene like this, and you have 4 people coming up, sitting in front of their computers, you have some funky music playing, and then you get 20 minutes to do something really cool. These guys are fast when they are programming, because they program just from what's in their mind, and this is the tool they use, Bonsamatic. I'm going to demonstrate a little bit of shader coding in my favorite tool, which is called kodelife. It's kind of like a shader IDE, and it's not free, but even you can try it, and you can use it for as much as you want, but every time you start it, if you don't pay for it, you get a little bit nag screen and say, you might want to pay for this. I think that's fair. And it's a really, I think, a really good tool, and it's sort of very interactive. And this is the tool I'm going to use today. So let's start by the circle, with the circle. Now, I am a little bit concerned, because during this sort of start, I got some crashes here in this tool, but I think hopefully I just have to restart it if it crashes, but we will see what happens. So, what is this? Well, this is a kodelife shader IDE. And what you're seeing in front of you is a program, because that is what a shader is. It's a program that allows you to do graphics. And this programming language is called GLL, which is hard to pronounce. And it's a OpenGL shader language programming language. There's also something called HSSL, which is even harder to say, which is DirectX shader language. But it's basically a C language, and I think as a C# developer, or JavaScript developer, or a Java developer, so you should be able to read this. You might not understand what it's doing, but this -1 + 2 should be possible to understand for a C# developer. It's essentially C. You remove classes, you remove object orientation, you remove all I/O, and you just do compute, basically. And what you're looking at here is a fragment shader. There are multiple kinds of shaders created for various purposes, where I only know 2. I know about vertex shaders and fragment shaders. And this is a fragment shader, or in DirectX lingo, pixel shader. And here's the most important thing I want to tell you today. What is a fragment shader? Because I think sometimes when we talk about shaders, people say, I got a reaction. No, it's too hard, I can't understand it, it's black magic, it's unapproachable. Well, a pixel shader, fragment shader, is fundamentally, I would say, quite simple. It's a function that given a coordinate, and in this case, here, an input, it's a little bit weird, but it's an input pixel coordinate. Your mission in life is to produce an output color, which is a WEC4, which we go into detail here. But that is what the pixel shader does. And then this function is executed on each and every pixel here, and this input change. And if you try to write this in C#, it doesn't work here, but you write it something like this: color, get pixel color, something like that, and you will send in like a pixel coordinate, ref struct probably, because the performance, P. And then what you do, you use this P thing here to produce a color. This is the pixel fragment shader. That is what it does. Then, of course, what's inside here can be very, very complex. But essentially, what it does is coordinate in, pixel out. let's talk a little bit about colors. So I say it's supposed to produce a color. So this program here, it writes the color here. I'll try to point with my mouse instead. It writes this color here, which we then write to the pixel color output. This is the alpha channel. If you know PNG, we just set it to 1. We don't care about transparency. So here we put the color. And now I can change this value here to sort of different values, and we see that the things changes here. So this program is now recompiled and deployed on the GPU and executed immediately. So this is not just hot reload. I call it the hottest reload, if you're and it actually works. There's a question here. Well, the requirement for the pixel is WAC 4. But maybe you can do a little bit thing, but it's a detail, yes. But in this case, we just ignore it. So, and the values here, we can also put in negative values, and when you put negatives, it's not like we suck light into here like a black hole. It just doesn't produce a color. And likewise, if I put in a really big value here, it's not like this. We are like looking to a nuclear explosion. We will turn it to vapor, because the valid values are between, not surprisingly, 1 and 0. So 1, white, 0, or like, I want to have light mode, dark mode. So anyway, so let's talk about this. Is called a WEC3. And what is a WEC3? Maybe. So if we write some C# code here for WEC3, it could look a little bit like this. So it's WEC3. If you're a C# or if you're a Java developer, you might say class. It doesn't really matter. And then you have a variable called x here, int y, and int z. This is a WEC3. And in this case, x will be red, y will be green, and z will be blue. And we can see that because I can initialize this WEC3 with different values. So if I type 0 to 5 here, we expect it to be red. And if I go like this here, it's green and blue. Amazing, amazing graphics. But we can actually now use the input coordinate we get here to make it a little bit more interesting, and also in a way inspecting the variable, because it's hard to put. You can't put a breakpoint here and stop, or you can't console log, because you get a ridiculous amount of console logs because there's so many pixels. But what we can do is we can inspect Q. Q is a variable here, which is a pixel coordinate, and we look at the Y variable. We get a nice looking red gradient. What this means is that Q.Y is 1 up here and 0 down there. And then we can do the same thing for X here. So we see that Q.X is 0 here and red here. Now, it is a program. For each pixel here, it produces a different color. And we can even make it a little bit more interesting by setting like so. So then we have a little bit of gradient that on the bottom here, with 0, 0, it's black. On top here, it's yellow. And here, there's nothing red, but only green. And down here, it's just red. And we get a little bit of gradient. And now this gradient won't, chip in units, so we make it better looking. And now we can finally sell our product. So, pretty good. So this is a very simple pixel shader. And honestly, in some sense, to explain the pixel shader, I could stop here. But maybe we can spice it up a little bit. And I want to talk about shapes. So, and this is the second most important thing, because why is this? I'm going to tell you about a mathematical concept, and lock the doors again, because we're going to talk a little bit about mathematical concept here called the distance field. But how can I illustrate it? A distance field is a function. They're given a point in space. This distance field function sort of represents an object. I'll try to use my bottle without spilling, but let's say we have a distance field that sort of would visualize this thing here. So if I take a point here outside in space, and I ask the distance field, it returns a value telling me how far it is to this bottle. If I take a point inside, it's hard to do it, but if you imagine like this, backhand, right? If I take a point inside this thing, I'm inside the object, then I get a negative value indicating I'm inside the object. And if I take a point on the surface of the object, it returns 0, indicating I'm on the surface. So if I put in solve all coordinates where distance is 0, I get my bottle. That is a distance field, briefly described. But the bottle is too hard for me to do, so I'm going to focus on something which is much more simple, and that is a circle. So I'm going to create a distance field for a circle. And this thing going to take the point P we're going to test against, and then we're going to send in the radius of the circle, and I'm going to return an amazing piece of math here. I'll take the length of P minus R, and then we try to explain why this makes sense from a distance field perspective. So if I put in 1 here, just to make it a little bit more concrete, if I take a point P that is far away from the circle, this length from the point P here will be bigger than 1. And then this will return a positive value. But if I take something inside the circle, then the length will be less than 1, and return negative. And if I take something on the circle, kind of by the definition of circle, all the points on the circle are at the same distance from the origo, then I get 0. So in some sense, it makes sense. So let's try to draw this amazing thing. So I'm going to do a float d here. Oh, that doesn't work. Float d equals like distance, right? Not the ring, circle p 0.5, like so. Okay, and now I have distance to my object. How the hell do I draw it? Well, I said if we are inside the object, if I'm inside the object, it's negative. So if it's less than 0, I should be able to set my color. Now hoping it is working, and I get a white circle. So I mean, applause. So amazing. Or maybe a slow clap. Really good. Anyway, we got a white circle. That's pretty good. But it's a start. We have to start somewhere. Let's add some movement to this thing here. So I'm going to introduce vect p0 equals p, right? And how do we animate? We're going to use the time variable here. So I said we only take a pixel coordinate, but the time variable is kind of like a constant for this frame. So there's a variable here called time that I can use, and I can set px plus time, like so. And then I start the time variable, and it goes outside the screen, and we never see it again. It's gone. So that's too bad. So now math again. So if I have something that is always increasing, and I want something that doesn't increasing, but instead goes a little bit back and forth, there's a function that kind of does that. So if you know, anyone want to make a try? Sine, I heard sine. No, wrong, cosine. No, sine is a very good answer. And now if I start a timer, it moves back and forth. You know, and everybody will obviously found my startup project with billions and billions of dollars when they see this moving circle. I'm sure about that. So let's spice it up a little bit, and we do here sine time, and now it goes that direction, like so. But that's kind of, you know, if you remember school again, this is math hour. You remember there might be a relationship between sine and cosine. They kind of sound similar, so let's try the cosine, and it moves in a circle. So never mind why. The thing about shader is a little bit mathy, but if it works, it works, and you don't have to go into these details why it works. But I want to have a little bit more fun. I want to have a bouncing ball. And in order to do that, I'm going to introduce a bouncing variable, float b, equals, I mean, it's hard to write this code, so it should be hard to read. So float b equals time, and then, but time is always increasing. There's another way to make something that repeats, and that is using a function called fraction, which kind of is the opposite to floor. It throws away. If you send in 10.0, you get 0.5 back. It's in 9.7, you got 0.7 back. It throws away the thing, and that means the value kind of repeats. It's the same thing. And then instead of using this thing here, I'm going to take plus b. It's almost bouncing. It's very bad bounce, but it's kind of bouncing. And then I kind of remember that, well, it should accelerate a little bit. So it starts slow, and then it accelerates. And I don't, by my intuition, let's multiply by b. That should do something, if I can find the right key. No? Has it switched the keyboard? Am I just... where is the thing? I'm confused now. It could have switched the keyboard, if I'm unlucky. Or I'm just... there it is. No. Brain problem. And I got one down there. And you see it kind of accelerates. It's not really good. But then the problem here is that this thing, it doesn't return to the original point. So it goes back and then immediately up there. That's not right. It kind of, at the end of the period, it has to go back to the same position. And the period of fract is 1 second because we have the 1. So let's go with something. It should have something to do with 0.5 then. So if we go minus 0.5, kind of like a bouncing ball, in my opinion. Go back and forth. It's kind of a little bit too little bouncy, so we're going to go b multiplied by 4, 0. More bouncy. And we take b plus 0.5. Wrong direction. Better. And this is very much how we work with these things. Like you take plus 5, it doesn't work. The minus probably works better, and then you go minus, and you see what happens. So don't think too much. Just try things. That is why I like this. So now we have a bouncing circle. Now, but it's kind of dull. We want to add some colors to our bouncing circle. And let's see the time. So I had 3 hours, right? No? Okay. So, oh boy, I have to speed up a little bit. So let's go now. Anyway, bouncing circle, some colors. And I'm going to introduce, you don't have to remember this, but I'm going to introduce a palette, and there will be, but the other things I mentioned, you have to remember. I'm going to ask you when you go out, and you can't go home unless you know it. So we have a palette generating function, but this function is amazing. Because it's so simple and it generates so pleasing colors to me. And I'm just going to type the formula because I have memorized that. I'm considering putting it on my gravestone. But yeah, so, and I'm going to explain it a little bit later what it does. I can't explain it why it looks good though. That I don't know. So the purpose of the palette generating function is I'll take a value A in, and if that changes, it should give me some kind of nice, smooth palette changes. And we use sign for that, because why not? Sign for everything. It's a cheap operation anyway in the GPU. And inside here I take A plus this. This means actually that I move A inside here and E here and here, but this is just a shorter way of typing it. And then we run sign on this vec3. And that just means I run sign on this thing here, this thing here, this thing here inside there, and return a vec3. And this vec3, the values inside vec3, because the way sign works, goes between -1 and 1. And that's not good for colors, because for colors it's supposed to go between 0 and 1. So I multiply this by 0.5 and plus 0.5, and it goes into sort of, right ratio 0 to 1. And now I'm going to use this amazing function. So instead of doing this, I'm going to call my palette generator function here, and I'm just going to set it a value. No, that didn't work. It's purple. Kind of like C# logo I see now. So that's good. But kind of a little bit dull. Since I talked up this function so much, you might be a little bit disappointed. So let's use this distance field again. And not much better, but if I take time 10, you see now we have a little bit cool gradient going on here. And it should be moving, so let's add a time to this. And it goes inside, but I think it should go the other direction. Go from inside out. So we have a bouncing ball of different colors that is slowly changing. Let's put a border around the bouncing ball, because that is a nice little exercise. So I don't know how to explain this really, but the circle has an inside and outside. It's hard to see when it's moving. Go back in time. So outside here, the distance field is plus. Inside here is minus. But if you create a border, kind of both sides are on the outside, and only the border is sort of, on the inside of itself. So we want to sort of make this circle till only the border should have an inside, and this should be outside. I don't know if that makes sense. It's though very simple to do, because I just take the apps value here, outside, or border, BD, let's call it BD, apps D, like so. And if you're inside the border, if the BD is less than 0, something happened, then the vec3 color should be 1, not 10. Nothing happened. Amazing. I expected that. The problem is that the border now is infinitely small, and obviously then it's not really visible. But if I take -1 here, it's very big. So if I go 0 to 5, it's less big. And now we start seeing a border appearing. 0 to 5. Which one is the best? It has to move for us to determine which one is best. Yeah, this looks good. Let's go with that one. So now we have a bouncing ball with a little border around it. What's cool about the distance field is this, what we just did here, work for any kind of distance field. So this circle is a very simple distance field, but the other distance fields do. Unfortunately, creating a distance field is a little complex affair. So, you know, I don't bother with that. I go to this site by IQ. He's a god amongst men and women. And he has provided this amazing site where you can see you have the circle distance field. Here's outside, here's inside. And if you need a box, here you go, here you go, here you go. I'm going to find a 5-star because I like that. Wasn't there a band called 5-star back there? They were good. People remember them, they know. So I'm going to use the 5-star thing. Now, this is a complex formula. Do I have to understand it to use it? No, I don't. You know, there are a lot of things I use at work that I have no idea how it works, and I just use it and I'm moving on. And I do the same thing with shaders. I have no idea what this thing does. I'm a little bit lying. I'm a little bit more knowledgeable. I know a little bit, but you don't have to understand all of these formulas here. If you want, you can try to, but you don't have to. I'm just going to use it here without bothering explaining it. It is a distance field, though, so it returns the distance from a 5-star. It takes a value p, which I hope is the same as my, where's my circle? There, p circle. And it takes an r, which we hope is the radius, and then it takes an rf, which I don't know what it is. So let's use that thing instead. Yeah, wow. It's not like it's going to blow up the universe. Hopefully not. Ah, amazing. Well, so let's see, 10. It doesn't look like a star still. What about -1? Not really. But let's take, okay, so we can see which one is the best. You know, it's so great to have hottest reload. When you just change the code, it just changes immediately. So good. So now I have bouncing star, but no, notice our outline border, everything just worked because the distance field is a generic concept. So when you model your code around the distance field, it doesn't matter what shape it has. It just works anyway. This is a brilliant abstraction, you know, the distance field. So what's next? Let's add some rotation. And then IQ, he can't do everything. So I have my own little site where I have a little rotation macro, which is essentially a function that sets up a matrix, but who cares? And I put this matrix in here. It's essentially a function. So, and now I want to do some rotation. And I want to apply the rotation just before I draw the star. So I take P0 times rotation 0. Nothing happened. But if I go like this, something happened. And if I go like time, it's slowly rotating. But so I just think it's fun. Let's sort of imagine that when the circle comes to the border, it kind of should speed up to sort of create the friction and go the other direction, right? That's kind of thinking. And then we have to take the derivative, obviously, of sine, called cosine. And nothing happens. But if I multiply this by 10, perhaps, yeah. So it's, you see, in the middle, and then it speeds up, go the other direction, like you can imagine the sparks flying. That's the next presentation. And so back and forth. Cool. At least I think it's kind of cool. Let's see. Did I write something what I want to do next? No. Well, let's make a for loop. So we want to have more stars. Because we all stars here, I don't know if that makes sense. So let's add some more stars. And the way we make more stars is we make a for loop to sort of repeat this code a few times. And this is one area where I have to be a little bit careful with shader coding, because if you put in an infinite loop, the GPU is going to disagree with that, because then each pixel has an infinite loop in it, and it's not going to appreciate that. And then the driver crashes, and you know, and we have to start off the presentation. So what I do there is I don't want this hottest reload anymore, so I just put in compiler error, so it doesn't compile properly. Because when you do this thing where you recompile obviously all the time, it's very easy to write an infinite loop, I noticed, by bitter experience. And then the GPU, then the code life crashes, and all my work is gone, and I have to start from scratch. So let's not do that. So I put it in here, and hopefully I write my for loop roughly right. So let's see if it works. Save. And we can indent the code as well. So the code police don't go for us. Let's see, something like that. And then I can increase my variable to 4. Nothing happened. 9. And why does nothing happen here? Well, the reason is we're painting the same star on the same position over and over again. But since everything is time driven here, what I want to change now, I want to introduce an iTime variable, which is time that is modified by the I variable a little bit. So let's do that. I'm going to float time, iTime, I said, equals time plus I. Okay, and that doesn't work because I have to do this. Yes, cast to float, and what I do, then I switch this to iTime. Nothing seemed to happen really. Doesn't something happen? Do you think I got all places? No, here we have it as well. Save. Look at that. We have 5 stars, and no 4. And it's the reason they call it bounce in unison is because I offset the time by 1, and the period of the bounce is 1. That looks a little bit boring. So let's take 3, 4, and yeah, maybe this is better. 8. I like 9 better. And then we can have 40 stars. Not really good. And that's not good for YouTube encoder. Let's crash the YouTube encoder. Yeah, there you go. Have that, Google. So let's see now what we're going to do next. Yes, so we built this thing here. We built some bouncing balls. Is there something else I want to do here? Is there something else I have time? How much time do I have before I panic? Yes. So I probably should go next step. Anyway, so I mentioned ShaderToy, and what we've done here, we can actually publish and for you, and I hope if I succeed, I will put in some links here so you can go to this on ShaderToy. But now I want to sort of take this code here and put it on a website so everybody can see this amazing piece of art. So let's go with that. So I go into ShaderToy and I click new, and I'm gonna put in here. So ShaderToy has a roughly the same syntax as kodelife, but there are some small differences. So I'm gonna remove all these comments here, and like so. And the main function is not called main; it's called main image for reasons unknown. And I'm gonna remove this thing here, and I'm gonna put in here, and then the out frag color we get in frag color here, and I think if I put in Q here, it might be right. There's a lot of might, and I've done this many times, but it's very different doing this sort of live. Eye resolution. Here we go. Yeah, they of course. Oh yeah, a lot of more errors. Yeah, well, it's okay. We can probably fix them. Times undeclared. Yeah, so I lost it unfortunately. Eye resolution. Yeah, done. Time doesn't exist because time doesn't exist because it's called iTime. And then we have a lot of errors here. I believe this is probably not so complicated. It's just that it's a little bit more picky, that it doesn't like if you don't put in integers when it expects floating points. And pixel color. Oh no, that doesn't work. And what is now the problem? Pixel color, frag color. There we go. It's running in the browser. And then I'm gonna type a name, and then if you go to ShaderToy, and then when I saved it, and then you refresh the screen on ShaderToy, it should show up in the most recent shaders on your phone, and hopefully it works. So Swetugg shader. No, probably should spell it correct, otherwise they get upset with me. Shader introduction. And 2D. Hello. And I click save. Wrong spelled hello. Doesn't matter. And public API. Yes, save it. And if I go here, well, hopefully saved it. If I go here now, on my screen there's a Swetugg shader thing here. So when I click that, it shows up. And I hope it shows up on your screen as well. Matthias, do you see something? It's there? It's bouncing? It's bouncy? Very good. Now we published our first to the cloud. So we're kind of cloud engineers. DevOps. So we put this on the ShaderToy so we can share what we do very easily for everybody to see and comment. I don't think this is going to attract so many positive comments, especially since I've done this 3 times and all see the same, so they're probably sick of it. The other people that are on the site. But you never seen it, or Matthias have seen it, but most of you haven't seen this thing, so you might like it. Yes. So now we have We have a few minutes left, right? Is it to 45? Or was it? It's 45, right? So so I have like 6 minutes before the wrap up. But this is cool, I think. You can take what you do, and then you can share it to the world and show what you got. And I said I'm going to put some links up here later. If you're interested to find more information, I'm going to put them in this shader. And of course, all of you click this like here, right? So I get some likes. Yes. So what shall we do? Should I spice it up a little bit? We can try to put in the Swetugg logo. That was such a big success last time I did this. So I have a texture here. So I'm going to bring in a PNG image, and that way it works here. You're going to bring in a texture, and then I'm going to load a Swetugg image, and I'm going to use the I'm going to use, I think, the Gothenburg one because it was more. I could probably find a good one for this one as well, but I think I like the one better. So here, down here, you see this loaded upside down for I don't know. And now I want to draw this texture on the screen, and I'm going to call this logo. I have to give it a name here, logo. And then there are some magic stuff that if I want to use this shader, I have to type like this. Exactly why, I don't know. I just learned that this is what you type, logo. So nothing happened. And then I'm going to make a function called Swetugg, which returns a vec4. And the reason it returns a vec4, here we have transparency in the PNG, and we want to use that. So we return a vec4, and I call this function Swetugg. And we go vec2p equals no. There. So, and does not return anything. That's okay. And then we return texture. That's how you sample texture in this thing. And then give the logo. Go to p. I'm done with the function. It's not really done, but it's good enough for now. And now I want to use and put this logo on top of the stars. So I get the L call, the logo call, and take the Swetugg. And I send in the p value. And how do I get it on the screen? Well, this vec4, so the first three are RGB, the second is alpha. So then you use a function called mix. So I say the call here is mix of the current call value and the RGB value of the Swetugg logo, XOZ, and then I'm going to mix it with the alpha of said thing, and it looks horrible. Great, and as I joked last time, now the Swetugg people are regretting that they ever invited me because I just murdered their logo. But we can fix that. Don't worry. So first off, it should be centered on the screen. So yeah, let's go for that. Yeah, slightly better. It's upside down. Well, in order to fix that, we're going to reverse the p.y. It's that direction. It has awful dimensions, and the reason for that is this is not rectangular, so it's kind of squeezed a little bit. So I have to compensate for that. So so I go like this perhaps, and then I take 1140. I'm reading on screen here how big it is. 385. No, that's wrong, right? And it's even worse. And when in shaders, when you do something and it's even worse than expected, you do the opposite, and then it's better. A lot of things I do is just like that. I try something and it's awful. It goes the wrong direction. Then I do the opposite, and very often, much, much better. And we can admire the Swetugg logo. Well, pretty good. Let's add some movement to this thing. So I'm going to take a backup. No, apparently I'm not going to do that. Put a space here in this thing. I'm going to take a new color, which I call LP equals P. And LP there, very hard to type. And we want to do some, maybe some sign thing or some going on. So it's waving a little bit. So what I do here is I take L plus X plus sign something, time. Okay. Not very exciting though. So then I'm going to take plus p.y here, I think, if I can type. Ooh. Maybe I'm invited next time. I get the probability increases. In a quantum computing world, I will be invited at least once. We can also add a little bit of rotation to this thing here. So it looks awful. But you know what's great about this thing? When it always compiles, that sometimes I type a horrible bug that looks great, and when you type it like this, and it just pops up something on the screen, oh, that looked good. And you go back and you see, this is obviously a very bad bug. I don't care, it looks good. The only thing that matters if it looks cool. Boring, that's never that. Weird, okay. I think I got some note that it's 10 minutes left now. So I'm going to wrap this up by trying to distort this a little bit. Ooh, yeah, got seasick. Hope you're not traveling tonight. Something like that. And then, of course, we can just make everybody even more seasick. So, yeah, something like that. Yeah. I think I kind of run out of time, but I hope you get it a little bit. So we created this program from scratch with a little bit of bouncing stars and the logo going around. You know, a little bit explorative coding, and see what we got. And it's all interactive coding. It's all hottest reload, trademarked. Don't you try using that. Microsoft, pay attention. I'm joking. So let's go back here. Now I learned something. Here we go. So let's wrap this thing up. I hope the code example made some sense to you, and I hope it reduced a little bit of stress around shader coding. A pixel shader is a function that, given a coordinate, produces a color. And the distance field is useful because you can do all kinds of cool things. And what I didn't touch on is the thing that really got into it. That's kind of an example of how nerdy I am, but you can do Boolean algebra kind of on shapes. Extremely simple with distance fields. That was kind of what blew my mind, and then I got into all this thing because I felt it can't be this simple to do Boolean logic, because if you do that with triangles, it's a pain. So I got into that thing. And also distance field, if you ever go to ShaderToy and look at ray marchers, which is 3D ray tracers, they all rely on distance fields. It's a fundamental concept. Anyway, talking about which, some good resources if you're interested in continuing. I think ShaderToy is where I started. I think it's a great resource. There are examples for everything. There are examples for the most complicated shaders you can think of. That nobody understands anymore because the author has forgotten how it works. So nobody understands it, but it looks pretty. And then there are shaders that are really, really simple. So there's something there for you if you want to start. It's a little bit like the Library of Babel, though. Like, there's so many shaders, so it's a little bit hard time finding it. But it's there. And I encourage everybody to publish what you got. Because even when you start, you might be thinking, you know, what I have is nothing. But there's someone out there on the same level as you, and they look at advanced shaders. This doesn't help me. What they want to see is the simple things. So there's a room for every kind of shader here. And I never had a problem with the community. I'm sure there has been, but for me, it's always been very nice. And this site is brilliant, and it's by the guy called IQ, and I can't pronounce his name. But he written an article for basically everything you need to know about shaders, and they are, I think, well written and kind of to the point and concrete. And yes, if you don't know and it's kind of like, you won't understand them if you read them without context, but when you start asking yourself questions like, I'm interested in finding out more about warped fractal Brownian motions, a question I often ask myself, there's an article for that. So, and then it makes a lot of sense, and it goes like, this is really well written. And by the way, this is all his shaders, and they're all, these pictures here are shaders that move, and they're all pixel shaders. A little bit more advanced than what I did, though. He's pretty good. And also there's a YouTube site which I recommend. This guy is known as Big Wings on the ShaderToy site. He's really good. He makes amazing stuff, and he has this YouTube channel where he goes from the start and shows you how to get started with some simple shader coding, and he does it all in ShaderToy, so you can follow along and pause and do the same thing he does. And the late ones are of course quite complicated, but should start from the beginning. And so I think this is well worth looking at if you're interested in learning more about ShaderToy. And he's really good. And there's another sort of site, another YouTube video which is called Introduction to Shader Art Coding by Kishimitsu, which is another name I can't pronounce. And this is amazing, well done introduction. But I think primarily a big reason for I recommend it is I just think this is really pretty for how little code it is. So that is the reason. And I'm also going to plug my own stuff, which is Windows Terminal Shader Gallery, which I appreciate, Matthias, you showed today during the thing. So, we all hate a boring terminal, right? And I'm not talking about fancy prompts or whatever. That's boring. What we want to have are some shaders in the background. So then we can pick one. We can pick the one I had there, which I called recursion. So this is a shader background. It's moving slightly. I know there are many F-Shop developers here. That's a joke. And F-Shop logo. But I also know that probably many C-Shop developers here. So a little bit C-Shop logo, moving a little bit. It's not very, a little bit subtle. So there's something. And also, plugin Matthias company here. I did this for WCOM as well. So shader for everyone. So if you're interested, you can download this on like a .NET tool install, and you're also welcome to contribute. I have a very low bar of contributions. Basically, it has to compile and run and not be obscene, and I'm good. And that's kind of it, guys and girls. Any questions? And did I manage the time? I have 5 minutes left. Yes, ShaderToy. The question was, is there a site called that you can see the most popular shaders? And I would say that is the ShaderToy site. That is the site for shader developers, kind of. Is there another question? Yeah, go on. If I can bring in mouse position? Yes, I can. So here, the question was, can I take in mouse position? I'm not sure if I have it enabled here. But you can bring in variable here, like the mouse position. Yeah, you see invert X, Y, Z, and I think you can get the mouse positions. And also on ShaderToy, the site here, can you get the mouse positions there? Here, if you go in here, no, where was I? Date, there we go. No likes. Okay. Well, I'm not sure I'm going to tell you now. But here there are some variables that you can bring in for your question, and one of them is called mouse, and then you can bring in mouse position and you can control it like that. You can also bring in sound here and get FFT, and so you can make sort of sound that Ericsson sound and things like that. And you can also interact with the camera to make TikTok-like filters and these kind of things. All possible here, so it's a very cool site, I think. Anything else? I put on the good glasses so I can see you. I see you now. Oh yeah, really cool. I didn't know. Very interesting. Well, shall we take an extended break then? 3 minutes. There you go. That was one presentation.